All right, ratios and proportions. A ratio is a comparison of two quantities using division. A ratio is a comparison of quantities using division. This ratio of quantities, A and B, can represent it as, all right, there's a bunch of different ways you can compare the quantities. In this case, they're talking about A and B. Here's one way, A over B, all right, just as a fraction. When you guys get your quizzes back, you take how many you got correct and you divide it by how many questions there were on the quiz. That is a ratio, okay? Another way is A colon B. A to B is a ratio. You've seen it as A to B. All right, you can write a ratio that way. You can use the backslash, A to B. All right, those are all ratios. Those are all comparison of quantities by division. Number correct, total questions. Could be miles driven in an hour. Hits per at bat. Okay, all of those are rates or ratios. Now down on the bottom of that page, an extended ratio. Extended ratios can be used to compare three or more quantities. The expression A to B to C, okay? A colon B colon C colon. All right, this would be read A to B to C. That's an extended ratio. And we did some problems this year where you were given an extended ratio of the angles in a triangle, okay? If the angles in a triangle were in the extended ratio of 2 to 3 to 5, okay? The angles in a triangle, the extended ratio is 2 to 3 to 5. What is the measure of each angle? Alright, and that's when you would draw a triangle, or you didn't even have to draw a triangle. But if the angles in a triangle are in the extended ratio of 2 to 3 to 5, okay, then one of the angles is 2 times x, another angle is 3 times x, and the third angle would be 5 times x. That's what that extended ratio means. So you could combine your like terms, you could make it equal to 180, and you could solve for x and then multiply and find each angle measure. So in this case you would have 10x equals 180. You could divide by 10. Your x would be equal to 18. And if you took that 18 and you replaced it for each of these x's, you could find each angle measure. Okay, so this angle down here, this 2 times x, this angle would be 36 degrees. This 3 times x would be 54 degrees. And then 5 times x. What's 5 times 18? 90? $90. So this angle up here would be 90 degrees. All right, turn the page. Okay, example 2 up there, the ratio of the measures of an angle in a triangle is 3 to 4 to 5. Find the measures of the angles. Okay, so another example right there, same type of problem. The ratio of the measures of the angles in a triangle is 3 to 4 to 5. So if you got the ratio of 3 to 4 to 5, and you're asked to find the measure of each angle, find the measure of the angles, you're going to take 3x plus 4x plus 5x. So 3 and 4 is 7, and 5 more, 12x. So in this case, 12x would equal 180. Alright, you can divide by 12. Your x would be equal to 180 divided by 12. That's 15. Okay? If your x is equal to 15, then one of the angles in this triangle, alright, would be 3 times 15, which would be 45 degrees. Another angle in the triangle would be 4 times 15, which would be 60 degrees. And then 5 times 15, the last angle, would be 75 degrees. Thank you. So those are the 3 angles in the triangle. Any questions on either of those examples? Alright, look down to the middle of the page there on page 462. Properties of proportions. An equation stating 2 ratios are equal is called a proportion. In the proportion, if A over B, which is a ratio, is equal to C over D, which is another ratio. Alright, here's an example of an equation stating that 2 ratios are equal. This A and D, those are called extremes. B and C, meaning the values in the bottom left location and the upper right location. B and C, those are called means. Alright? Upper left, lower right, those are called extremes. Bottom left, upper right, those are called means. Okay? In a proportion, the product of the means equals the product of the extremes. And I'm pretty sure we've done this already this year. Alright? And the rule is in a proportion, or when one fraction is set equal to another fraction, cross products are equal to each other. Okay? A times D is equal to B times C. That's how you solve a proportion. Okay? So if you look at the top of page 436, and you're given the proportion 6 over x is equal to 21 over 31.5. Okay, and you're asked to solve each proportion. You just crisscross multiply. Okay? The order doesn't matter. So if you like your x on the left, you can take 21 and multiply it by x first, so that's 21x. And you can make it equal to 6 times your 31.5. And 6 times 31.5 is 189. Okay? If you divide each side by 21, then your x is equal to 9. In example B on that same page, you've got x plus 3. X plus 3 over 2, and it's equal to 4x over 5. Okay, again, the cross products in a proportion are equal to each other. So in this case, you can take this 2 times 4x, and that would be 8x. And you can set it equal to, now in this case, you got an x plus 3 times 5. So I'm going to write it as 5 times x plus 3. You have to do the distributive property here. Alright, so 8x is going to be equal to, we've got to take 5 times x plus 5 times 3. So 5x plus 15. Subtract 5x from each side. And 3x equals 15. Divide both sides by 3, and x is equal to 5. Any questions there? Solving proportions. Okay, and then this last example, example 4, use proportions to make predictions. Car ownership. Fernando conducted a survey of 50 students driving to school and found that 28 owned cars. If 755 students drive to his school, predict the total number of students who own cars. When you're given a problem like that, and you're going to be given those all this week, and they're going to be on your quiz, you're going to make a prediction, and you're going to make your prediction by writing a proportion. So look, example 4 there says, Fernando conducted a survey of 50 students driving to school and found 28 owned cars. So if you write a proportion of students, okay, over owned cars. Alright? So your first ratio would be your 50 students, and out of those 50, 28 of them owned cars. That's your first ratio. So 50 to 28, or 50 over 28. And then you make it equal to, if 755 students drove to school, so now you got a 755 over, the question is, predict the total number of students who own cars. So who owns cars is down here in the denominator on the bottom right, so that's your variable. So you write two ratios, you set them equal to each other, alright? And now you can solve for x to find out how many students own cars. So when you crisscross multiply, 50 times x is 50x. Just set it down. And 28 times 755. It's 21,140. So if you divide both sides by 50, then your x equals 422.8, so we're going to make it, our prediction would be 423 students own cars. Clear? Any questions on writing a ratio or solving a proportion? All right, your assignment today.